Hmm. So today we are going to start learning C programming. Okay. So we are not going to jump into history of C and theory of C, nothing like that. We are going to write one program and then learn how this program is built, how this program is run. Okay, then we'll go ahead. So let's create a simple program first. Hello world. We'll use the Vim editor for this program. I'll call it hello.c. Okay. Now, in this program, hash include stdio.h and the main function, which is the entry point into C programs. All the C programs will start from main only. Return 0. We will print hello. That's it. Hello. That's it. Then we have to compile this program. To compile this program, you will use GCC hello.c. The program will be compiled and a.out will be created. There you see a.out. We run a.out. Okay, fine. This is output. We got it. Now we'll start analyzing it. Yeah. Well, history of C, I told you, will not go into this. You can read it and come back to me if you have any doubts. So we will be learning C for why? For what purpose? We'll be learning using C for these purposes. Some examples of C. We'll be using C for operating system development. No need for language compilers now, but the C is used for this purpose. We won't do that. We will be using for operating system development. C. We'll be using C for network drivers, for some many drivers, many drivers. Some modern programs like system programming and network programming, all these things we will do. So we'll be primarily using C for database operating system development and device driver development. System programming, network programming, these four things. Okay. To work with the C, we need four things. We'll be using C for, I told you, operating system development. We'll be using C for Linux system programming. We'll be using C for Linux network programming. And we'll do projects in this. We'll do device driver development. So many drivers we'll do. Some protocol design and development also we can do if we go for some advanced training. And operating system development, obviously. So these are the five things that we will be using C for, developing and working on C for these things. To work with C, we need these four things. These four things must be there, and you must be hands-on with these things. First, we need an editor where we'll write a program, and that is going to be our Vim editor. As you saw just now, I compiled my program using GCC. So we'll need a GCC compiler. We need a debugger. Debug our program when our programs become a little complex later on. We'll need to debug it. And finally, a revision control system, RCS. This will be used for source code control. So these four things we need to be able to work on C programs. Now, when you start with Vim editor, all three of you, you people have done some work on with me using Vim. Okay, but if any of you have any doubts using Vim, then you can tell me now. Manish, please put your video on. You know how to use Vim? Give me thumbs up. What do I have to tell you? Mayank says okay. Ankit also say okay. And what about Manish? Well, because his video is not on, so you can't, it's irrelevant. So we know how to work with the Vim. I'm skipping this part. Compiling, you compile using GCC. GCC is a compiler and it gives you a.out, which is XSky output file, and you can compile it and run it using ./a.out. But if you compile your program and you don't want to give name as a.out, you want to give some other name, That also you can do by using -o option. For example, if I do here also, I want to compile my program like this gcc hello.c, but I don't want the output file to be named a.out. I can give -o means optional name. Optional name you can give an he hello. So you see, you've created hi for hello. We run it. Okay, so you can compile like this. Very first thing in here, the compilation. So here hyphen o means -o means optional name for the compiled file that we created. New file will be created. Okay. So this is for -o. That is the optional name that will be given. -o. So like this, there are many flags with GCC. I'll keep on telling you all the flags one by one. This is -o means -o gives new name to the compiled file. And this is the name of the compiled file. Let me give you the whole image actually. Your Jamboard. That will be better. Yeah. So -o is the key new name for the compiled file. So this is how you'll be compiling your programs. Okay. Now we wrote a program just now, hello.c. Let's analyze and learn from here. This is called preprocessor directive. Whatever line starts with hash is processed, is taken care by a special program in operating system called preprocessor. There is a program called preprocessor. Whenever you try to compile a program, before compilation, there is pre-processing that happens. The directive preprocessor tells the preprocessor, directive hash include, this is your directive. The directive hash includes tells the preprocessor to include code from the file stdio.h. There is file called stdio.h. Include all the code from there. I'll tell you how to do that. This file contains declarations for functions that a program needs. The stdio.h needs declaration for printer. Okay, that's why this has to be included. Okay, now this is the whole story here. What happens is this hash include will be taken care by the preprocessor. Whenever you try to build your program, GCC program name.c, it will go through this 4 steps. Preprocessor first, second compiler stage, the preprocessor stage, the compiler stage, the assembler stage, and the linker stage. The program will go through these 4 stages. Okay. Now, very first thing what happens is preprocessor. Preprocessor will look into your program, all the lines that starts with hash. Like you have this line, yeah, starting with hash. So preprocessor will work on this line. Okay. It will see that okay, it is hash include. Hash include means there is some file stdio.h that has to be included in your code. So preprocessor will start doing that work. The preprocessor will go to a special path /usr/include. There is a path called /usr/include. At that path, you have all the header files. I'll show you. That will already have. Let me give this. the prompt format. Okay. If I go to cd/usr/include here, you see all the header files that are used by C programming is found here. One of these files is stdio.h. If we open this, then you'll see inside this, you will find a declaration for printer. There, line number 363. There is a declaration for printer. Do you see that? It is because of this declaration that the GCC compiler is able to understand, okay, GCC printf is some library. Otherwise, it will give error. It is because of this that the whole stdio.h has to be included in your code. Okay. So, from the set of header files that you find at /usr/include, stdio.h file will be identified, will be found out, and will be included in your code. So, your code was hello.c, one. But over that, you put stdio.h. So there are now two files put up in one file. Okay, two files put up in one file, and the file will be called hello.i, I for input. This will go as input into compiler. This is how the code is prepared before compilation. Okay, let's have a look at this, how we can create hello.i. That is from GCC -e hello.c redirect to hello.i. Enter. See, hello.i is created. When we open hello.i, there you see, this is whole stdio.h. The whole file stdio.h has been pulled up by hash include directive that is taken care by worked upon by the preprocessor. The preprocessor have hash included the whole stdio.h into your code, and towards the end of your code, this stdio.h and towards the end you'll have your hello.c code. See, this was your program at the bottom, but your program is now prefixed by whole stdio.h, and this big file having 817 lines is now supplied as an input file to your compiler. The compiler starts working. This is what the compiler will get to compile. Is it okay? Any doubts, any questions you have? Feel free to ask me immediately. Yes, Mayank, tell me.
Sir, hyphen E stands for?
Sorry?
What is hyphen E stands for?
Hyphen
Hyphen
E.
E.
Hyphen E that I use here is an option. This option will make only the pre-processing happens and nothing beyond pre-processing. As you saw there was a pre-processing stage. After pre-processing, there is compilation stage. After compilation, there is assembler, and then after assembler, there is a linker. So there are 4 stages in C program build. So if you use -e, that will stop after first stage. That is, cause only pre-processing will happen, and nothing beyond pre-processing will happen. -e. It makes the program to be processed, pre-processed rather, by the preprocessor. The preprocessor will work on only those lines that starts with a hash sign. Okay, so this is what is done by the pre-processing. And to make a program, pre-process and then stop from further build, we make -e. -e makes the program pre-processed with a preprocessor. After pre-processing the program, the build process stops. Means compilation phase is okay, but after compilation, after pre-processing phase is okay, but after pre-processing, nothing happens. You create hello.I, that's it. Nothing else happens. It stops after that phase. So if you want your program to stop after pre-processing, use -e. And the new output file hello.I is created. Hello.I. This hello.I file. Follow the colors, okay? I'm color markings. This is for hello.I. The hello.I file now would contain both stdio.h and our hello.c, both codes. Okay. This file would be the input file for our compiler, GCC. Okay, this is how it works. Any questions? Nice. Let's go ahead. Now, compiler. The control have come to the compiler now. Compiler. Now, this compiler will work like this. Compiler actually looks like this. The compiler that we are going to use, this compiler have 1, 2, 3, 4, 5 stages. The first stage is called syntax analyzer. It looks at the syntax and semantics of the program, if your program is written correctly or not. Second is lexical analyzer. It look at declarations and mapping. Suppose you've declared some pointer. Is it mapped to the memory? Memory is allocated successfully? Yes, no, these kind of things. Then you have intermediate code generation. It converts the whole program into symbols, okay, which are interpretable by the compiler. Then you have code optimization, optimize your code with respect to reducing redundancy, with respect to space, with respect to time, all these things. Now, all these 4 stages will be taken care of, and this is called first pass. See what I have written. The GCC compiler, okay, it is a 5 stage, 1, 2, 3, 4, 5 stage, 2 pass compiler. 2 pass means these 5 stages will be parsed once and then twice. So these 4 stages will be parsed once. This is called first pass. In the first pass, it will do some task. I'll tell you what task. Then this is the code optimization phase. Now, when the compiler starts working in the first pass, it will do during the intermediate code generation phase, it will create a symbol table. It will create a symbol table. Now, in your program, whatever you have declared, some variables, constants, functions, pointers, whatever you have declared, everything will be listed in here. All declarations. All declarations. Links, you have used printer, maybe scanf, sqrt, whatever libraries you have used. All those libraries will live in some other directory, that is /lib or /lib64 or some other library somewhere else. But in the symbol table that will be created at intermediate code generation, is you will have links like this. Links only. Okay. So when the first pass is over, the symbol table is created by that machine, and the created symbol table will have a listed everything that you have declared, and also it has links to all the libraries that you have used. Now the first phase after the code optimization, first phase is over, and the second phase of the compiler starts. The second phase of the compiler will compile a program, and every time it sees, oh, printf, what is printf? Compiler is going to give error. But before giving error, it checks the symbol table. Do you have anything called printf? Well, the links will show that, okay, there is something linking to a set of libraries, and one of those libraries are called printf. Okay, then printf is a library. It will proceed further. Okay, suppose you declare integer I. It will say, what is integer I? Again, the control will go to the symbol table. There it will find a declaration for integer I. It will understand, okay, I is an integer. It will not report error. It will go ahead. So like this, the second pass of the compiler will do actual compilation. And for everything that it is not able to understand or find, it will look at the symbol table. There it will find the declaration for it. Okay, and it will compile the program, two pass compiler. The second pass of the compiler begins, and it will use all the entries that are made in the symbol table in the first pass of compiler. The first pass of the compiler, let me give you this also as image in your discussion board. You should have the whole story with you. The first step towards learning C is to learn how the program is built. And second step is to learn how the program is executed. Then you start coding. Okay. So this part is also there. Now the compiler, which have 5 stages and 2 pass, will work through all the 5 stages and 2 pass, and finally produce a file that is the compiler's output file called hello.s. The hello.s will contain set of symbols and a reference to symbol table, from where you have further reference to libraries like printf, scanf, sqrt, whatever. Okay. If you want to see this file, I'll show you this. The command to get a hello.s file is gcc -s. There you see. Hello.s is created. Let us have a look at hello.s. Oh, this is assembly. So the output of the compiler is actually assembly. And people say that the output of the compiler is object file. That's not right. You can see it's happening in front of you. The object of the output of the compiler is assembly, but we don't have to learn assembly. Assembly could be generated. Somebody may spend 2 years to learn good assembly level coding, but we can do it in seconds. We don't have to learn it, isn't it? So output of this will be an assembly code. Hello.h is an assembly code. This is the command to get that. There this goes into your discussion board as next stage. Here it is. I am giving you for a reason, these pictures. I'll tell you the reason towards the end of today's session. Okay. Now we proceed further. The hello.s is further supplied to assembler. The assembler will work at the assembly level code and produce actual output file, hello.o. This is the object file, relocatable, connectable. Okay. So you can produce many hello.o files, and then towards the end, you can link all the hello.o files into one executable file. That also I'll tell you how to do that and why we should do that. That also I'll tell you. Okay. So the hello.o is prepared, and this is fed to a linker. Now, what is this linker? Link. What linker will do is, suppose this is linker stage. See, initially we had hello.c. We gave it to C process preprocessor that produced hello.I. Then hello.I was given to the C compiler that produced hello.s. Then the hello.s was given to assembler, it gave hello.o. Now hello.o will be given to linker. What linker will do, remember I told you, symbol table contains links to the library. Linker will use those links to go to the library, bring in actual printf, scanf, SQL, whatever libraries you have used. Linker will link all those libraries to your .o file that was created here. All relevant, maybe there are 2, 3, 4 object files. Linker will link everything. Other object files, some libraries you have used, printf type, all will be pulled. Everything will be linked. After linking all the files that are linked, supposed to be linked, linker will link all the required files and produce a final executable file, which is your a.out. That a.out is created and will be stored in secondary storage, not memory. It will be stored in secondary storage. Okay. Linker will link everything, create your executable file, and your executable file will be stored in secondary storage. Stored in secondary storage. But when you have to run it, you can't run it from secondary storage. You have to run it from memory, RAM. Okay. So how it will run from RAM, that we'll see in the coming days, coming session. But yes, I hope you are able to understand C build process. If you go to your C code in C line, C, this. If you go to courses in your members area, and then you go here, click courses, and the courses you will have number 1, that is project C programming and data systems on Linux. Session number 1 is some introduction to C, compiling C programs, how to compile all these things. If you want, you can read. Mandatory class assignment is here. 2 assignments. Look at the first one. Write a program to print hello world, you can do it. Easy. Look at the second one. Open that C program. First, you write a C program and compile it. It will give you a.out or whatever other name, hello, and you can compile it. That's done. Then, open that C file again and add some error in that. Like remove some semicolon from here or whatever type of error you can introduce. Save and close the file. Recompile it. It will show a syntax error. Read that syntax error and understand it, what it is actually saying, compiler. Then prepare a soft copy, a document, in which you tell what was the error you introduced and what was the response of the compiler. For example, I have a hello file here, hello.c we wrote, isn't it? We wrote hello.c. We'll open it. And we will introduce, oh, it's already open here. And we'll introduce some error in this. Say I remove this semicolon, the easiest one. Okay, and save and close it. Okay. Then we compile it. Then we compile it. Head gcc hello.c. It gives you error. So you will prepare a document. No, document like this. Text document. Number 1. You'll tell what did you do? Remove semicolon from printf statement. Then compiler gave you error. You will copy the error. Control Shift C. Copy. And here Control B. Now you'll copy paste here only when you understand what was the error. So this was the error you give, and you understand the response of the compiler. Line number 5 in hello.c says this is missing. expected semicolon before return. Did you see that? Isn't it? So you have to understand. And then copy paste here. And then I want repeat this for 20 different and unique errors in the Hello World program. 20 different type of errors. No error should be repeated. This document you will prepare and then send to me. Remember, 20 is the target and no error should repeat. By doing this, by the time you finish this assignment, you will be able to understand most of the errors that are reported by compiler, the compiler's language. This will make your and my life very easy. And we'll be able to do further things with ease. Okay. So this was an introduction to C. This is how we start C programming. You see here, number 3A. C program build steps is given here in this notes. The 3 series, 3A, 3B, 3C, 3D, 3E. It explains you about pre-processing, preprocessor output, then compiling, -I to -S, the assembling stage, the linking stage, some additional steps also there, debugging, optimizing, generating assembly code, static and dynamic. Just have a look at this and try to do this. Okay. Try to do this as an exercise. Yes, Manish?
Sir, library का मतलब क्या होता है सर? Explain करेंगे. Libraries. What is meaning of libraries?
Library, an example of library is printf. Now, what does the printf do? In your program, you have given a string, this word called hello. That hello has to be taken out of your program. Through the data bus, it will go to screen. And using the display driver, it will be displayed. So this is a very complex task. So all the complex tasks that are supposed to be done, but you as a new developer cannot do it. So all the complex tasks are put up in a library. Either complex tasks or repetitive tasks are put up in a separate program, compile, build, and the executable version is provided to you as a library. So these are some common tasks and very repeated tasks and complex tasks which should not be done by the programmer. It should be done by the system or maybe GCC, and that should be provided to the developer. Thank you. Later on, I'll give you a broader explanation of the library, and we'll create our own libraries also. Okay. Then there is another document here, build step pre-processing. The pre-processing step stage is elaborated here. You just go through this. It's a very important step. Then you have step 2, that is compiling. Then you have step 3, assembling. Step 4, linking. These 4 steps that I explained you now. So there are wonderful notes, so they are ready for it. You just go through it. Okay. Just go through it. This is very handy notes, very important. If you don't feel like reading, then you can take breaks, but you have to read it once. Don't try to move up. Just read it. Okay. And yes, the mandatory class assignment, that is document number 15. That is this. 20 different and unique errors. Give me that document, okay? Is that okay? So it's the first day in C today. So just beginning. Saturday, Sunday, you have time. You can prepare your assignment and give it to me and read these 5 documents which I said. Okay. So we'll continue Monday, Wednesday, Friday. C programming will go on 5 a.m. I have resolved my saga. I'll wake up at 5 p.m. and be available to you. Okay. So 5 a.m. class is the best class in the day. Always. So that's all I got for you today, and I wish you a good day ahead, and see you on Monday. Bye.
Thank you, sir. Bye, sir.